The next very important chapter of trigonometry is inverse trigonometric function. Inverse trigonometric function. Now the first point is, when will inverse of a function exist? When will inverse of a function exist? Very, very important point. Now remember, if f is a function from a to b, if f is a function from a to b, and if it is both one-to-one function and onto function, if it is both one-one and onto, that is, if f is a bijection, one-one and onto is meaning is bijection, then its inverse, that is f inverse, exists. And f inverse is a function from b to a. F inverse is a function from b to a. And f inverse is also a bijection. Remember, whenever any function is to possess inverse, it should be both one-one and onto. That is, it should be a bijective function. That is bijection. Otherwise, function cannot possess inverse. That is why all trigonometric functions, are not bijective functions. Are not bijective functions. But by restricting, very, very important point, but by restricting the domain, domains of the function, but by restricting the domain of these functions, we make them bijective. We make them bijective. We make them bijective. Otherwise, basically, trigonometric functions cannot have their inverse as such if domains are not restricted. Therefore, let us start defining one by one inverse trigonometric functions. Now the function f from minus pi by 2 to pi by 2 to minus 1 to plus 1, defined by fx equal to sin x, is a bijection. Now earlier I told the domain of sin x is R in the first basic chapter of trigonometry. But if the domain of sin x is restricted to closed interval minus pi by 2 to pi by 2, sin x becomes bijective. It is both 1, 1 and onto. Therefore, inverse of sin x can be defined. Then f inverse from minus 1 to plus 1 to closed interval minus pi by 2 to pi by 2 is also a bijection. If the domain is restricted, then it becomes bijection. Now this function is called inverse sine function. And it is denoted by sine inverse x, or sometimes we write arc sin x, sine inverse x or arc sin x. So remember, very, very important point. When will inverse of sine function exist? When will inverse of sine function exist? Inverse of sine function will exist only if the domain of sin x is restricted to closed interval minus pi by 2 to pi by 2. Because basically the domain of sin x is R. Now for example, what is sine inverse of 1 by 2? Generally, sine inverse of half, if we don't know this point, we write it as 30 degrees or 150 degrees. But because the range is from closed minus pi by 2 to plus pi by 2, therefore we should write only pi by 6. Because sine pi by 6 is also 1 by 2. Sine 5 pi by 6 is also 1 by 2. But we don't write sine inverse half as 5 pi by 6. We write only pi by 6. Very, very important point. Now let us come to second inverse function. Now the function f from closed interval 0 comma pi to minus 1 to plus 1 defined by fx equal to cos x. Fx equal to cos x is a bijection. Now once again remember, basically the domain of cos x is R. But if I restrict the domain to 0 comma pi, if domain is restricted to 0 comma pi, then only cos x becomes bijective, that is both 1, 1 and onto. Then f inverse from closed interval minus 1 to plus 1 to 0 comma pi is also a bijection. This function is called inverse cosine function. Inverse cosine function, and it is denoted by cos inverse x, or sometimes we write arc cos x. Arc cos x, cos inverse x, both are same. So remember here once again, if domain of cos x is restricted to 0, pi, then only inverse of cos x will exist. Otherwise, cos inverse x cannot be defined. That is why in earlier there was one discussion, what is cos inverse of root 3 by 2? What is cos inverse of root 3 by 2? Generally, cos inverse of root 3 by 2, we can take 30 degrees or 330 degrees. But we should write only 30 degrees, that is pi by 6. Because cos pi by 6 is also root 3 by 2. Cos 11 pi by 6 is also root 3 by 2. But we should not write cos inverse root 3 by 2 as 11 pi by 6, because 11 pi by 6 is not in the range of 0, pi. Therefore, we write it as only pi by 6 radians. Very, very important point. Because earlier discussion we had what is cos inverse of root 3 by 2. So therefore, there we wrote only pi by 6 but not 11 pi by 6. Very, very important point. Now let us come to the next inverse function. The function f from open interval minus pi by 2 to pi by 2 to r defined by fx equal to tan x. Defined by fx equal to tan x is a bijection. Then f inverse from R2 minus pi by 2 to pi by 2 is also a bijection. This function is called inverse tangent function. It's called inverse tangent function. And it is denoted by arc tan x or tan inverse x. Arc tan x or tan inverse x. Now for example, what is tan inverse of 1? Tan inverse of 1, is it pi by 4 or is it pi plus pi by 4? Is it 5 pi by 4? We write tan inverse 1 as pi by 4. Generally, Tan pi by 4 is also 1. Tan of pi plus pi by 4, that is 5 pi by 4 is also 1. But we don't write 5 pi by 4 here because the range of tan inverse is between minus pi by 2 to plus pi by 2. Range is between minus pi by 2 to pi by 2. Now similarly, tan inverse of minus 1, we write it as minus pi by 4. We never write it as 3 pi by 4. So these are the important basics when we try to find the inverse of the function. Therefore, these things should be known before we discuss the values of inverse trigonometric functions. Now let us write here, let us write domain and range of inverse trigonometric functions. In the first video, we wrote domain and range of all 6 trigonometric functions. Now let us write domains and ranges of inverse trigonometric functions. Domains and ranges of all 6 inverse trigonometric functions. Domain and range of all 6 trigonometric functions. So let us draw one table regarding domain and range of all the 6 trigonometric functions. So let us try to divide this table. In the first column, let us write the function. Second and third column, let us write domain and range of the function. First column, function. Second column, domain of the function. Third column, range of the function. Third column, range of the function. Now, first function, sine inverse x. Domain, minus 1 to plus 1. Range, closed interval, minus pi by 2 to pi by 2. Okay. Second function, cos inverse x. Second function, cos inverse x. Domain, minus 1 to plus 1. Range, 0 comma pi. Third function, tan inverse x. R. Range, open interval, minus pi by 2 to pi by 2. Similarly, cot inverse x. Domain R. Range, open interval, 0 comma pi. Secant inverse x. Domain, minus infinity to minus 1. Union 1 to infinity. Range, 0 to pi by 2. Union pi by 2 to pi. And last function is cosecant inverse x. Domain, minus infinity to minus 1. Union 1 to infinity. Range, minus pi by 2 to 0. Closed at pi by 2. Union 0 to pi by 2. Closed at pi by 2. Open at 0. Now, this is the domain and range of all 6 trigonometric functions. Now, in the next video, we will try to discuss some more useful and important properties of trigonometric functions.